Coming up next, Mathematics in Focus for students of grade 8. The Guyana Learning Channel, taking you on a journey to success.
Sometimes in mathematics we encounter a lot of problems. Welcome to mathematics class for today. In this lesson, we will be studying circles. In particular, we will focus on the circumference of the circle. We will discuss how the circumference of the circle is related to the radius of the circle. And of course, we know that the radius is already related to the diameter. So then we will use this relationship between the circumference and the radius to help us to solve problems involving the two. Further, we will use the relationship and we will use the fact that we can solve problems involving these two to actually apply it to some real-life situations that involves the use of circles. Good afternoon, students.
Good afternoon, sir.
Welcome to our mathematics class for today. In this lesson, we will be looking at circumference of circles. What will we be looking at?
Circumference of circles.
Good. And I know everybody familiar with circles, right?
Yes,
Everybody?
Yes, sir.
Good. So when we will be examining circumference of circles, for example, we wouldn't only be looking at a circle, but we will be looking at cylindrical objects. Like, for example, we'll be looking at these, the cylindrical objects. We may be looking at spherical objects also. All right? Because all of these are circular in nature, right? Spherical, cylindrical, and then we can also talk about, everybody know what's this, right?
Yes, sir.
Good. So we can talk about these two. They have the circular property about them. So we'll be looking at the circumference for all of these different shapes and solids. Now in this lesson, we will be investigating circumference. Then we will be trying to find the circumference given a radius of a circle or a sphere or a cylinder. And we will also be solving problems involving circumference. Good?
Yes,
Are we ready to go?
Yes, sir.
All right, me too. Okay. We have the circumference. We have a circle. Imagine we have the circle. And we have this arrow here pointing to the circle. We have this arrow pointing to the circle. It's indicating circumference. What do you think is the circumference really? Anybody? Oh, so many hands. All right, let me get it. Yes, what do you think it is?
The distance around the circle.
The distance around the circle. Is there anybody who agree with her?
Yes, sir.
You sure?
No, sir.
You don't agree with her. What do you think is the circumference?
The circumference in the border of the circle.
The border around the circle. So we have the distance around the circle, the border around. So now we have a third answer. Yes, what you have?
The perimeter around the circle.
The perimeter. But I think all three are saying the same thing, huh?
Yes.
Anybody agree with me that all three of them say the same thing? The border, the distance along, the perimeter, they are speaking about the same thing. Alright? So when we speak about the circumference of the circle, yes, we're saying that the circumference of the circle is the perimeter. Let's get this good. The circumference of the circle is the perimeter of the circle. Alright? Or the distance along the circle. So we're all correct. Good? The distance along the circle. Good. Then we can talk about the diameter, the radius. What is the diameter?
Sir.
All right. Yes. So the back.
Sir, it is a straight line that passes through the center of a circle.
A straight line that passes through the center. You sure you don't want to refine that a little? Because look at this. Is this the diameter of the circle? It's a straight line. It is passing through the center. So what is the difference between this line in red and this one in black, which has diameter mark on it? Can the diameter be outside of the circle?
No, sir.
So the diameter is a straight line which is drawn from one point on the circle to another point on the circle, but it is passing through the center. Alright? The diameter is a special chord. Now we also have the radius. Can somebody tell me what is the relationship between the radius and the diameter? Somebody once told me that the radius is 2 times the diameter. Is that correct?
No,
What is it?
half.
The radius is half the diameter. Good, correct. The radius is half the diameter. So we see here, for example, if we extend the radius backwards, we're going to have, if we extend the radius backward, we're going to have the radius completing a diameter, right? So one radius, a second radius will give us the diameter of the circle, right? So the radius is half the diameter. Yes. The big question is, what is the relationship between the circumference and the diameter of a circle? What is this relationship, you know? Is it one bigger than the other? Is it less than it? Can we establish a relationship, a usable relationship between the two of them? All right, that's what we're going to be investigating. So, what do we need? We need some tools to carry out our investigation. We can get some string, as we see here. We can have some string, a cylindrical object, or a circle, or a spherical object, any object which we want to find the circumference and diameter of. We have a set of instruments there, the set squares, rulers, and so on. And then down here, we have this here, we have the vernier caliper. But most of us wouldn't have a vernier caliper in our homes. We would most likely have our instruments in our homes. So we're going to demonstrate how we can find the circumference, how we can find the diameter of a given circular object, and then we're going to compare the two, see how they are related to each other. So, are we ready for this investigation?
Yes.
Good. So I will ask on 2 students to come and help me with this investigation. And please come, let us help with this investigation. Remember, we're going to be firstly measuring the circumference. So we're going to first be measuring the circumference, and we will be taking some instructions as to how to go about doing this. We will be taking some instructions as to how to go about doing this. So we have some instructions here. So can I ask another student to come and help us with the instructions? And we will follow the instructions. And the same thing when you're at home or when you're in your class, you can also follow the similar instructions. Yes, what is the first thing we need to do? Okay, we can make a knot at one end of a piece of string, but in this case, we're going to use our measuring tape, which already has a mark at one end. So just locate the start of the measuring tape with the centimeters. Good. Yes, what's next? So if you don't have a measuring tape, then you could use a string. So we're going to place the knotted end, or the end of the measuring tape, at one point on the side of the circular object. So which one are we going to measure? Oh, you're going to work with the ball. Okay, good. So mark a spot on the ball. Yes. And what else we do? We need some instructions here. What else we do? And we pass the string, or in this case the measuring tape, once around. And we identify the point where it gone once around, right? Yes, what's next? Now if we're using a string, then we take the string and we put it on a ruler. But since we're using a measuring tape, do you agree that we already know what is the length? Good. So what is the last thing that we need to do? Write down this value. So what is the value you get for the circumference of this ball?
35.
35 centimeters. So can everyone please write down 35 centimeters? So what we have is, we can write down the value, this value C. So we have C is equal to 35 centimeters. So for this particular case, we have C equal to 35 centimeters. Good. So we have the diameter, the circumference of our ball. Good. So now we can go on. Let's move to the next set of instructions. Now, what we're going to do now is going to help us to form the equation. But before we proceed, just do you agree that the circumference is usually bigger than the diameter? The distance around the circle will be bigger than the diameter. So, what we have is, for example, here, it's like a seesaw. Right here where we have the C. So imagine the circumference is here and the diameter here. If the circumference is bigger than the diameter, well then most likely this side is going to be heavier. Alright? So it is not equal at the moment. So what we want to do is establish a relationship whereby when we take the circumference and the diameter on this seesaw, it's going to be level. So we want to do something with the diameter or something with the circumference which is going to make it level. Good. So what is our next instruction? Using a vernier caliper or the set squares and ruler, obtain the diameter of our object. You just use a ball. So can you obtain the diameter? You're going to use a ruler here. You might turn that ruler around, turn that set square around, please. Sorry, no, around this way. Good. And we have the set square. It is starting at, observe what they're doing there. They're taking the set square and it's starting at 20 on the ruler. They put the ball, and sure you have the full diameter of the ball. Let's just get it in line here. Just hold the ball in here, in this position. And they put the ball there, touching it. And then they put another set square in the other end of the ruler. And they see where it ends. Where does it end?
31.
31. So we start at 20 and we end at 31. So what is the diameter of the ball? 11 cm. So we have the diameter to be 11 centimeter. What is our next thing there? So please write down 11 centimeter. So at this stage, we have our diameter is 11 centimeter. Good. Now, our next instruction says, what? What does our next instruction say, class?
Divide the circumference by the diameter. Write down this value.
Are you finished doing that? Well, please do it quickly now. Divide this. You already have the value for the circumference. Let us go back and see what is the value for the circumference. We already had it as 35 centimeters. And now we have our diameter as 11 centimeters. So dividing the two, let us see what we have. We have circumference divided by the diameter will be 35 divided by 11. And I would like for you to tell me the answer quickly. 35 divided by 11. Yes, what's the answer, anybody?
3.18.
3.18. All right, we have 3.18. Now, if we continue with all of these circular objects that we have here, there's an interesting property that we will find, out. What is the next instruction there? Repeat this process for different cylindrical objects. And the next one is saying, denote this common ratio. Yes, this is what we will find out. We will find out that even if we use this one, if we divide the circumference by the diameter, we're going to have a value somewhere nearby 3.18. Right? For all circles. That's a special property about all circles. All right? And we have a final instruction. And now we form the equation. Now, let us see. Okay, thank you very much. Give them a clap. Thank you. Good. All right. So, what we have here is that we're saying that this common ratio of all circles, it is not necessarily 3.18 because I guess we would have been approximating when we calculating there, right? When we're measuring. But it's somewhere around 3.1. But this common ratio, if we denote it with this symbol pi, this symbol is, pi is a Greek letter. It's a letter from the Greek alphabet. All right? And we call it pi. And so what we're going to do now is form an equation with c, d, and pi. Now, we're saying to denote this ratio. Which ratio? Isn't it this ratio we're talking about?
Yes.
Denote this ratio with pi. So how do we write it? We can say c divided by d. What is this equal to? Yes, what are we saying here? We're saying denote this common ratio with pi, which means is to let this common ratio be the same as pi. So we're going to use pi to represent this common ratio here. Good. So that's what we did there for our final instruction. We form an equation with the circumference, the diameter, and pi. So we see how the circumference is related to the diameter. That if we take the circumference and we divide it by the diameter, we will always get a constant value. And it is standard international all over for us to denote this value or to represent this value with the Greek letter pi. Good, let us proceed with our lesson now. The circumference and the diameter has the relationship as we mentioned before. However, in most books, if you were given the circumference and the diameter passing through the center here, and you were given the circumference and the diameter, in most books, how it is written is that rather than saying C divided by D is equal to pi, it is usually written as C is equal to pi multiplied by D, as is shown here. Okay? So rather than the equations mean the same thing, right? C divided by D is equal to pi is the same as C is equals to pi times D. For example, let us consider if we have 12 divided by 2 is equal to 6. Doesn't this mean the same as to say 12 is equal to 2 times 6?
Yes,
It says the same thing. Alright, so that's what we're saying here. C divided by D is pi, so the same as to say C is equal to pi times D. But remember, the diameter and the radius share this relationship where we say the radius is half the diameter. Or in other words, we could say the diameter is 2 times the radius. So rather than writing D here, rather than writing D as in this case here, we can replace this D with 2 times R, 2R. So we could replace D with 2R. So if we replace D with 2R, then we will get 2 pi, we get pi times 2R, which is the same as 2 pi R as is given here. Good? So either one of the two formula that we use for circumference and diameter or circumference and the radius. Good. Now, the value of pi. The true value of pi is an irrational number. And we know that an irrational number, if we express it as a decimal, it will keep going on and on and on. We will keep dividing and writing, and we will start from now. We're going to get big, we're going to get children, grandchildren, get old and gray, and we're going to still keep dividing and writing because it just keeps going on and on and on. So that means if we're going to write the value of pi, we can only approximate it. We can only approximate pi. We cannot write the true value of pi. So we will approximate pi, and usually for different persons approximate pi differently, but all the approximations are close. But in this lesson, we're going to use pi as 3.14, or we're going to use pi as 22 divided by 7. So that's what we're going to use pi for in this lesson. Good. So let us take some examples. First example is how we see directly how pi and the circumference and the diameter are related, or the radius related. First question. Find the circumference of the circle with radius 7 centimeters. Find the circumference of the circle with radius 7 centimeters. What do we want to find?
Circumference.
And what information the question gives us? What do we know? We know the radius. So is there a relationship between circumference and radius? Let's just go back a little. Is there a relationship between circumference and radius? Do we see that relationship here?
Yes, sir. Yes, sir.
There is a relationship between the two. So we can use this relationship to help us to find the circumference. So what do we say? We say that C is equal to 2 pi R. And then we just substitute what we know. So we can say this is equal to 2 times pi. The question is telling us to use the approximate value for pi as 22 divided by 7. And the question gives us the value for R as 7 centimeters. So what do we have? Remember, when working with fractions, we can always cancel, though,
Yes.
before we just go multiplying everything. So we have 7 in the denominator, 7 in the numerator. We will cancel 7 into 7, 1, 7 into 7, 1. So we just have 2 times 22, which is going to give us 44 centimeter. Good? Any question? So we see how we can find circumference given the radius, which is very nice. Are you confident about your answer?
Yes, sir.
Okay, because just in case you're not sure, hidden here we have the solution. You sure you want to see the solution?
Yes, sir.
Alright, let us see what the solution is. Is it the same as what we got?
Yes, sir.
Alright, good. So, at least we have one correct. Let's go to the next one now. Now it's not asking us to find the circumference. Instead, what is it asking us to find?
The
The
diameter.
diameter. And what information the question is giving us? Circumference. Yes, we want to find the diameter and we know the circumference. So, let's see. Is there a relationship between circumference and diameter?
Yes, sir.
Is there an equation? So we can use that equation to help us to solve the problem. And what does the equation say? Circumference is equal to pi times the diameter. Now, this is nicely laid out if we want to find the circumference, but now we want to find the diameter. So we can rearrange this equation a little. All right? If we want to keep diameter by itself here, then we can divide here with pi so that we cancel out the pi. These two go, and now we just have diameter by itself. But it's an equation. Imagine you were on a scale and someone sit on one side of the scale. Imagine you were on a balance and you are over here, someone else is over here, and it is balanced. And then this person jump off. This person over here jumps off. What will happen? If this person over here jump off, what will happen to you?
Sir, it will go down.
This will drop, so it will no longer be balanced. All right? Good. So we don't want that to happen in our case here. So we need to do something about C. What did we do over here? We divide with pi. So we need to do the same thing across here. We also need to divide with pi. So we have the nice equation which says that D is equal to, over here, C divided by pi. And we can use this to solve this problem here. Okay?
Yes, sir.
But I'm not going to solve it for you. Quickly, find what is D. Divide C with pi and tell me what's the answer. Good. Equal again. All right, that divided by that. Yeah, divide. Put the line. No. Divide here. Sorry. Let's put that here. Yeah, so divide here, divide by pi, which is 22 over 7. When we divide with a fraction, what do? Upturn and multiply. So we put equal to. When work decided equal to. Right back to 55. Yeah. Times multiply by, and now you upturn this fraction, it will be good. Is there a common factor for 7 and for 22 and 55? What is it? 11. Good. Well, then we can cross off. Use this to cross off. 11 and 22 is 11 and 5. Good. So now you just have 5 multiplied by 7. Use this one. Is equal to centimeters. 50 centimeters and N. Okay. Thank you. Thank you. Good. Nice. All right. So when we divide 35 with 2, what do we get?
17.5.
17.5. And we're confident about our answer again, right?
Yes, sir.
So if I check there and should I check there?
Yes, sir.
Alright, let's see. Yes, 17.5. So we're correct. Alright? Good. So let us see our next problem. So that's example 2. Let's go to example 3. Alright now. And now I will see those who really know their mathematics. Tom has a BMX bicycle with 63 centimeter diameter wheels. How far along the road will his bicycle travel when a wheel makes a complete revolution? What does it mean for the wheel to make a complete revolution? Come on, speak up. What does it mean? For the wheel to make a complete revolution, yes.
Go around.
How many times? For it to make one complete revolution, to make a complete revolution, remember we said it makes a complete revolution. How many revolutions? 1. So how many times it go around? 1. Alright, good. So complete revolution means that it goes around once. So imagine he's riding this bicycle and it goes around once. You know, all of this go around once. And it's asking us to find what is the length of this line here. Now, how is the length of this line relating to this bicycle wheel? What is the relationship between the two? If this go around once, do you agree that the entire edge of the bicycle wheel will be traced along the road?
Yes, sir.
And what is the edge of the bicycle wheel called?
Circumference.
So when the question is asking us to find the distance it makes for one complete revolution, in other words, what is the question asking us to find? The circumference. Good. So the question is basically asking us to find what is C. What is the circumference of this bicycle? All right? So how do we find the circumference? So we want to find the circumference, and what do we know?
The diameter.
We know the diameter. And there is a relationship between circumference and diameter. We know that the circumference is equal to pi times the diameter. The question gives us pi to be 3.14 times the diameter, which is 63 centimeters. So when we multiply this 3.14 times 63 centimeters, what do we get?
197.82
197.82 centimeters as our answer. But I mean, I'm thinking by now I wouldn't even have to check this solution because you have been right so far. So I don't need to check it, right?
Yes, sir.
Oh, because you think you're right again.
Yes, sir.
And let's just check it, all right? And just ensure that you're right again. Let's see. Yes, it's 197. Yes, 0.82 centimeters. Good. Let's take one more question before we go. This is a nice one. Find the perimeter of the shape below. This entire shape we want to find the perimeter of. Is there anyone who see two shapes there?
Yes.
Let's combine to form this one. What are the two shapes? A semicircle and a rectangle. Alright, it's not a square. If it's a square, then all the sides will be the same, right? Semicircle and a rectangle. Do we know to find the perimeter of a rectangle?
Yes, sir.
Do we know to find the perimeter of a semicircle? Semicircle, how is semicircle related to a circle?
It's
It's half. And do we know to find the circumference of a circle?
Yes.
So if we want to find the circumference of the semicircle, what do? Divide by 2, because it's half of the circumference of the circle. Good, so therefore you're supposed to solve the problem already. Okay? So what we will do, we will solve it in 2 parts. So we refer to this part here of this shape. We refer to this part here of the shape as S1. And we can refer to this part here as S2. Good. So we can find what is the perimeter of S1. So do you agree that the perimeter of this part of the shape here will be this 12 plus this 16 plus the length up here?
12.
And what is the length up there? 12, yes, because we get it from down here, so it will be 12 centimeter also. And since this length over here, from here to here is 16, well then we can also say that the length of the circumference is 16, right?
Yes.
And you telling me yes too? Huh? Is this a straight line here?
No, sir.
No, this is not a straight line, this is a curve. So we cannot do the same thing. We have to go and find what is the circumference here. Okay? Good, so we're going to find what is the circumference there. So we can write that the perimeter will be equal to this distance of 12 plus 16 plus 12. And then we're going to have plus this half of the circumference here. So we're going to have plus half of the circumference. Okay? So when we add up this first part, what do we get? 12 and 12, 24 and 16 will give us 40. And then we will have plus half. How do we find the circumference? It is pi times the diameter. What do we use for pi? So it will be 3.14 times the diameter. What is the diameter of this?
60.
Yes, the diameter will be this distance from here to here, which is the same as on the other side across here. So it is 16. So we multiply this by 16. And when you work this out, we will have 40 plus, well, half of 16 is 8. So it will be 3.14 times 8. And we will get this answer to be 40 plus 3.14 times 8, then we will get 65 point something.
Yes, sir.
What is it? 65.12 centimeters. We put our centimeter there. That's our perimeter which we just found. Alright? And I know again, you students are very good students, so this is going to be the correct answer. Alright?
Yes.
Good. Let's just double check again that it is indeed the correct answer. We have 65.12 as our answer, 65.12. Good. Very good, students. So we come to the end of our examples. Let us just summarize our lesson. The circumference, just remember, circumference is just another word for the perimeter. If it's a circle, then we call the perimeter of the circle the circumference. And it has a special relationship with the diameter, whereby we say that the circumference is equals to pi times the diameter. Now remember that this symbol here, we pronounce it as pi. It is a Greek letter, pi, and it has a special value. It is, we discussed that it's an irrational number, so we always approximate it. In this class, we approximate it by either these two values. And we can use this relationship here with circumference. We can use this relationship to help us to solve problems involving circumference, radius, or diameter of a circle. Now we will conclude with our homework. And you have your homework here given to you. You will use your mathematics for secondary school books in Guyana, book 2, and you will complete the exercise on page 37 and 38. And you will do many more problems too. So whether you go online, whether you go to the library, pick up as many math books or papers or links to different sites and solve as many problems as possible on circumference of circles. Now that we know how to work with circumference of circles. All right? Do you have any questions?
No, sir.
Okay, I like this class. You don't have any questions? Okay, well, next time I will be asking you some questions then, since you have no questions for me. All right, well, we come to the end of our lesson today. It was nice working with you, and I look forward to seeing you again.
Now that we have come to the end of this lesson, I hope that you can take with you much knowledge about the circumference of the circle and how we can use it to solve problems around us. Remember the special relationship between the circumference and the radius
which can also be modified to be a relationship between the circumference and the diameter. Let us use this relationship to solve problems which we will come across in mathematics and problems in general. Sometimes in mathematics we encounter a lot of problems